Hi guys. So the last big topic that we need to go over in the math section of ACT Prep is plane geometry, which is a lot to do with shapes and properties involving shapes that you may have forgotten. So this entire week we're just going to be focused on looking at the plane geometry part of the ACT. So we're going to start on page 244, which is kind of just sets up the basic approach for how to solve geometry questions. Okay, so I'm going to skip that first problem and just go down to the middle part. So here is the basic approach that we're going to use for geometry questions. It says, if the question does not provide a figure, draw one on your own. Write any information given by the question on the figure, and then write down any formulas you need and plug in any information you have. And so with these problems, it is important, first of all, that you know how to draw the figure, right? So you know your vocab with your shapes, and then also that you have your basic formulas memorized. If it's a more complicated formula, for example, like a volume of a 3D figure or something, usually they'll give you that. But basic, area formulas, you're going to have to know those, okay? So for this question, it says, an artist designs a rectangular wall hanging that is 24 inches by 80 inches. The artist also designs a triangular version of the wall hanging that has the same area as the rectangular version. If the triangular wall hanging has a base of 60 inches, what is its height in inches? So, a couple figures that we need to draw here. First, it says that we have a rectangle that is 24 by 80. Then we have a triangle that has the same area. The base, so the bottom, is going to be 60. We are going to be looking for the height, okay, of this triangle. So, a couple formulas we need here. We need to know the area of a rectangle, which that should be a simple one. That's just length times width. So if I take 80 times 24, that gives me an area of 1,920, which they told me is the same area of the triangle. So I need to set up my formula for area of a triangle. I know area of a triangle is 1/2 base times height. So I know the area is 1,920. I know the base is 60. I'm solving for the height. So 1,920 equals, so 1/2 times 60 is just 30. So then I can just divide by 30 to solve for the height, and I should get 64 inches. Okay, so this would be, a pretty straightforward geometry question. You use rectangles, triangles, you use formulas for area. And again, you're just writing down what you need and then using that to solve. Okay, so now we're going to go back to page 228 and kind of start with some basic formulas. Again, all of these formulas, they do expect that you have memorized. I know a lot of you have already taken practice tests and stuff, but I just want to point out that there is no formula sheet, okay, a separate formula sheet that sometimes you get with an EOC or something. ACT does not have that. Okay, so squares, a lot of times they label the sides of a square with S because they're all the same. So the formula for the area, they say it's just sides squared. Okay, rectangles, so you've got your length and your width here. So the area is just length times width. A parallelogram, remember this is what a parallelogram looks like. So opposite sides are parallel. There's a lot of properties that go along with this, but when you're finding the area, you need the base and then you need the height, which is that distance, right, from the top to the bottom. And so the area is just base times height. Triangle, we went over that, is 1/2 base times height, okay, which it's going to be similar when you're drawing it. Base is always the length of the bottom, and then the height is this distance from the bottom to the top. So what is the area of the shaded region of rectangle ABCD? Go ahead and pause this for a second and see if you can figure this one out, and then you can hit play when you're done. The shaded region is just a triangle, so it's 1/2 base times height. The base here, if you kind of want to think of this as the base, right? and then this is going to be your height here. So 1/2 times 5 times 8 is 20. For the next one, the dimensions of parallelogram LMNO are shown below, are given in centimeters. What's the area? So again, a pretty easy problem as long as you have the formula memorized, right? It's a parallelogram, so the area is base times height. So base is going to be the bottom length, so 9. Height is the distance from the top to the bottom, which they give us, that's 4. Be careful because that 5, that slanted length, you don't need when you're finding area. So 9 times 4 is 36. Okay, next thing is perimeter. Remember, anytime you're asked to find the perimeter, what you're doing is adding up all the sides. Right? And then for circles, and we're going to spend a whole day kind of more focused on circles, but for now we'll just go over the basic formulas here. Area of a circle is pi times r squared, radius squared. Circumference is pi times the diameter, or you may have seen it as 2 pi r. Remember that the diameter is just twice the radius, so these are really the same formula. So, quick question over circles here. What is the area of a circle that has a circumference of 14 pi? So, the circumference, what they give us, that's 2 pi r. And we know that that's equal to 14 pi. So I can get rid of the pi or just divide that out. So I am left with 2r equals 14. Divide by 2 to give me the radius, which is 7. That's important because I need the radius in the formula for the area. Area is pi r squared to be pi times 7 squared, or 49 pi. On this one, they leave pi in the answers, so you do not have to multiply it out. If they gave decimals as answers, there should be a pi button on your calculator, so you could just multiply that right there. If you don't have it or can't find one or whatever, remember pi. It's 3.14. It goes on forever, but you can just use that. Basic volume formulas that they do expect you know. Cube. So we all know what a cube looks like, right? Squares on every side. So the volume, again, it's kind of like a square where they label the side with an S. And so it'd be side times side, or S cubed. A rectangular solid is, just think like a box, right? That's length times width times height. And then a cylinder. Think about basically any shape that has common bases. So the bases here would be these circles on the top and bottom. If you've got a shape that has two bases that are the same shape, in general, you want to think about the volume as finding the area of the base times the height. So for a cylinder, since the base is a circle, the area is going to be pi r squared, and then you multiply by the height, okay, of that cylinder. Height would be your distance, right, between your bases. Okay, so pi r squared h. So here's our problem. The volume of a cube is 64 cubic inches. What is the length in inches of one side of the cube? They tell us it's a cube, so I know the volume is s cubed. So 64 is equal to s cubed. So I can just take the cube root here on both sides to get rid of that. That leaves me with s equals 4. Okay. I do want to go ahead and go through this page. These are common words or phrases that you find in word problems involving geometry. And so I just want to make sure that if you see these, you kind of like, it should pop in your head what you're looking for. So if they're talking about like tiling a floor or something, a lot of time they're asking about the area, right? How much space is going to be covered with that tile. If they talk about a tire revolution, they're talking about the circumference, right? The distance all the way around a circle. So that's a clue that you want to use that formula for circumference. If they talk about fencing, they're usually talking about finding a perimeter. Anytime they use units that are cubed, that is always talking about volume, right? If you think, find the volume of a box, it's length times width times height. That is three things that you're multiplying together, okay? So cubic feet. So down here, inches cubed, that's also going to be volume. Anytime it's anything squared, they're talking about the area. Think length times width of a rectangle. They're multiplying two things together. Okay, so anything squared is going to be area. If I jump down here, square centimeters, that's area also. Laying carpet, that's similar to tile. They're usually asking about the area. Ribbon, this one always confuses me. I don't know how many questions the ACT uses with ribbons, apparently a lot. They put perimeter. Honestly, I would just say length. I don't know. That's a weird one to me. Water, they're looking for volume. Oh my gosh, and I just wrote water. Whoop. Volume. Let's see, laying brick. Again, that's going to be area, kind of like tile or carpet. And then snow usually is volume. Okay, so just one more practice problem here. A rectangular dance floor has a tightly stretched rope running around its perimeter. If the dance floor measures 20 feet by 30 feet, what is the length in feet of the rope? So, you know, they specifically tell us the rope is going around the perimeter, so they're wanting us to find perimeter. So, you know, with rectangles, opposite sides are equal, and we just need to add all of these together. And we should get 100. Okay. So now I want you to jump to page 236. For the next few pages, it is vocab and then facts about figures. There is a lot going on here. I am not going to go through all of this because they have the answers. It says it's on page 723. And so if you're not sure what any of these mean, you can jump there to get a definition. If you're still not sure, you can always Google it and use pictures to help you or whatnot. But if we were in class, I would have you make flashcards for basically pages 236 through 241. And actually 242, it looks like, gives those definitions. So never mind, let's see here. They're right there for that page 236. So if you don't have, you know, flashcards at home or whatever, you don't necessarily have to make these. But it is important because there are literally 5 or 6 pages here of properties, formulas, definitions that they assume that you know for the ACT. If you jump to page 240 and 241, all of those formulas they're expecting you to know, which some of them we have already talked about. What I usually suggest is only make note cards for the ones that you didn't know, right? When you read it, if you were like, yeah, I already knew that, then there's no point in making a note card for it. But if you read it and you were unsure about it, or, you know, a trapezoid, maybe you don't remember the formula for the area of a trapezoid, that's fine. Make a flashcard for it, and then, you know, right before you're about to take the ACT, like the week before, just go through those flashcards every night. I really think that this will help you, especially if you struggled on those problems with the geometry. Remember, you can always go look back and see how you did on your pre-test and what sections of the test you didn't do as well on. I feel like a lot of times it is plain geometry because there's just so much to remember. So that's kind of what I recommend for those pages. We will have a WebEx on Thursday. So if you were going through any of that and had questions about it, you can jump on and ask me, or feel free to email me, okay, if you have questions on anything. So then the last thing I want to talk about, all the pages were not available for PowerPoints. So last thing I'm going to jump to, go back to page 245. and it's this idea of ballparking. So for the geometry questions where they have the figure drawn for you, usually there's like a little spot either at the beginning, I think it's at the beginning, that says, you know, pictures are not necessarily drawn to scale, but they always are, okay? They put that warning out there so people can't go back and say, you know, the picture messed me up or whatever. But if the drawing looks like, you know, a right angle, if they have that square, then that's going to be a right angle. If it looks like an acute angle, you can assume it's an acute angle. So the whole point of ballparking is that with these geometry questions, sometimes you'll be able to eliminate multiple answers just by looking at the picture and estimating, okay, your lengths or your angle measures. So this is a really good one. 38. In the figure below, points X and Y lie on the circle with center O. Segment CD and segment EF are tangent to the circle at X and Y, respectively, and intersect at point Z. One thing real quick. Tangent to the circle just means touching the circle at a single point. So X is touching the circle right here at one point. Y is touching at one point there. If the measure of angle XOY is 60 degrees, so I'll label that, what is the measure of angle CZF? So remember, you go side, vertex, side, so CZF. So I am trying to find this angle measure, okay? Just by the picture, you can tell that that's bigger than a right angle, right? So I can eliminate anything smaller than a right angle. I'm down to two options, 120 and 180. We all know that 180 is a straight line, and obviously this is not a straight line. So I know that my answer is J, and I did not have to use any properties that they wanted me to use. They want me to use the fact that this inside angle here, I would double it to find this angle, which would give me the 120, right? But if I didn't remember that property, I can still get this answer right just by looking at the picture. Okay, so that is definitely a strategy that I would use when they draw the picture for you. Ballpark, find, you know, an estimate for the answer, or at least eliminate answers that you know are wrong based on the picture. So here's one more I want to go over. In the figure below, segment MNQ is a straight line and all lengths are given in inches. What is the ratio of the area of quadrilateral NOPQ, so this one first, to the area of quadrilateral LMNO? So they're wanting me to look at the areas, right, of these two figures and compare them. Okay, so I know that the area for the red here is smaller, right, than for the blue, or sorry, for the green. So I can go ahead and eliminate E because that one has the wrong direction. I can also tell that, you know, the one on the left is significantly bigger, right, than the one on the right. So I would say that 3 to 5 and 9 to 10 are too close together. And so, you know, just by looking at the pictures, I'm already down to two options. Now, I think these two are too close. You know, I don't think that one is obviously wrong. And so for this one, I don't think we could get exactly the right answer just by looking at the picture. I think we would need to go ahead and do the math to figure it out. But we're down to two options, right, instead of 5, okay, which gives us a better percentage of guessing it correctly when we're down to 2. All right. The answer, if you do want to figure this out, it does end up being B. So yeah, one of the biggest strategies that we use in the geometry section, you know, if you know how to do the problem the mathy way, then you should. Usually it's faster. But if you're unsure, go ahead and use ballparking to help you at least eliminate some answers and see if you can get down to 2 or 3 that you can guess between instead of all 5. All right. So there's not going to be any like extra homework assigned because this video is obviously almost 20 minutes long. So for this week, we're just going to be going through some practice problems together. If you want any extra practice, starting on page 255, those are all like the homework problems for the plane geometry section. So you're always welcome to go there and work on any of those problems that you want. You should have the answers in the back for all of those. Okay? Thanks, guys.